Good afternoon, everyone. Today I'm going to talk about my research. My research investigation of low resistance on cadmium selenide P3HT active layer by using the transmission-line method. So let me talk about outline. Today I'm going to talk about solar cell background. The second, I will talk about objective of this research and discussion, and finally I will conclude my talk. But let me talk about organic photovoltaic device concept. You know, nowadays we usually use two different structure solar cell. In case of multi-layer organic solar cell, practical maximum efficiency was 6.5%. But you know, in multi-layer organic solar cell, it's very difficult process, very expensive, high cost. So nowadays many people concern investigation in case of bulk heterojunction solar cell. Why they concern in bulk heterojunction solar cell? Because this solar cell is simple and economic production, run-to-run processing possible. So in our research also in case of bulk heterojunction solar cell. So let me talk about polymer solar cell in case of bulk heterojunction solar cell. In polymer fluorine, efficiency was 5% by use of P3HT PCBM, and polymer efficiency was 2% by use of P3HT and red PM. And polymer and organics efficiency was 2.2% with P3HT and cadmium selenide hypercranch, and 1.6% in case of P3HT and zinc oxide nanocrystal. In our research, we also use P3HT and cadmium selenide quantum dot. Next, let me talk about main feature of polymer inorganic VHA solar cell. In this structure, ITO were used at the ITO cottage glass and were from contest. And Pilos VSS used as a transparent layer in composite film. In active layer, we use semiconductor nanoparticles, nanocrystal, CdSe, and polycide, P3HT. And back contact, we use lithium fluoride, aluminum. Let me talk about hybrid solar cell using cadmium nanoparticles. You know, in organic photovoltaic device are limited by poor acetone dissociation, but in case of bulk heterojunction solar cell design, we can improve acetone dissociation and also expand interfacial area. In our research, we use P3HT polycide as donor material, cadmium selenide nanoparticles as the acceptor material. And here in the figure you can see this structure in our experiment. Now I will talk about objective in this research. First I will talk about synthesize cadmium selenide quantum dots with varying properties. Investigation effect of surface exchange on optoelectronic properties, effect of heat treatment on the surface morphology and power conversion efficiency, and finally we try to measure electrical conductivity of composite layer by TLM method. Now, let me talk about synthesis cadmium selenide by colloidal route. We use hot injection method. After we follow this process, we have cadmium selenide nano-gridstone catalyst with topo, but we don't want to use topo coated CdSe because topo very high temperature, very high boiling temperature. That's why we change to topo coated to building coated CdSe. You can see in the figure in here we get cadmium selenide were coated by topo, but after exchange we use liquid process. After exchange we have building coated CdSe. In this research we also investigation in kind of topo coated CdSe and building coated CdSe. You know, for making composite solution, we try to many different solvent to try solvent to better make composite solution. So you know, polyside very polyside depends strongly on the quality of solvent. P3HT insoluble in high polar solvent, but soluble in solvent of intermediate polarity. You can see in this example, chloroform, toluene, chlorobenzene, and dichlorobenzene. We try to investigation solvent by polarity and boiling point. So we observe that the best solvent for use in our experiment, suitable solvent in this column and unsuitable solvent in this column. And finally, we also investigation roughness where surface roughness by different solvent. So we found that chlorobenzene, DCB, chloroform, and toluene were chosen for our experiment. You know, nowadays many people use single solvent to make composite solution, but in our experiment we try to mix two solvent, binary solvent neutral. In this case we use chloroform and chlorobenzene with pyridine. We can see in the morphology and the surface was investigation by AFM and SCM. We have very nice morphology and very nice surface. So for binary solvents we use chloroform and chlorobenzene with pyridine. So with investigation, pyridine concentration in binary solvent on the surface morphology. In the figure, you can see in case of pyridine around 20 and 30% in binary solvent, we get very low roughness. But in case more than 30% pyridine concentration in solvent, we get very high roughness. Why we get very high roughness in case of more than 30% pyridine in solvent? Because you know P3HT insoluble in pyridine. So if we put more than 30% pyridine in solvent, at that time P3HT will be put more than 30 with P3HT we precipitate. So that's why we use pyridine in solvent less than 30%. So we also investigation by AFM in case of chloroform chlorobenzene with pyridine. So after we have very standard solvent, very standard solution, commercial solution, we try to investigation effect of heat treatment on the surface roughness. So in this study, we try to annealing sample by after string coat composite film, we annealing. So we investigation by AFM. You can see in the figure, non-annealing and after annealing we have less than roughness, surface roughness very low. If we compare in case of non-annealing. So bulkhead Trojans and solar cell also fabricate by this procedure. First, ITO patterning, wet cleaning, surface treatment with natural plasma, ultra performance, annealing, and aluminum deposition, encapsulation, and finally with testing by solar simulator. So after investigation, heat treatment, we get some result. In the left side figure, we can see we investigation efficiency depend on annealing temperature. In case of 140 degrees, we get maximum efficiency. In case of pyridine coated CdSe and total coated CdSe. And in the left side, we can see article cell after pre-annealing and process. In this one is process condition. So beside material related problem, interface problem, morphology, surface morphology problem, we also try to know property of material in interface active layer. So it's so that if we reduce only contact by low specific contact resistance, that's why we use transmission line method to measure resistance, contact resistance of composite film. Now I'm going to talk about measurement of contact resistance procedure. First, ITO were patented by photolithography technique. After that, sample were cleaned by TCE acetone methanol for 30 minutes by ultrasonics. After that, composite film was spin coated at 3000 RPM and dry in oven vacuum. After that, we measure the contact resistance by using rod station. Now let me talk how to measure resistivity, contact resistance. Okay, in this figure, we first measure contact resistance, total resistance in two pairs. After that we get an article like this, and from article characterization we can calculate total resistance, contact resistance, shift resistance. So after that we can know specific contact resistance. So after measure resistance, we get some data. We get some data like this. In this data, so that if we add more, if we increase loading amount more than 50 milligram, we can say CdSe system decrease. That means calculation point was developed. We can see in case of chlorobenzene and chloroform, we get the same curve. So that we thought. So after investigation in this objective, we get optimum condition for bond of pressure. Finally, let me talk about conclusion. Solvent with intermediate purity, such as chloroform and chlorobenzene, are found to dissolve and polarize very well. And binary solvent neutralizing peeling ineffective in dispersed CdSe in polycyclic matrix. The surface roughness of hybrid thin film decreases after heat treatment. Free annealing effect of free annealing on the cell efficiency and the surface morphology and percolation pathway could be developed with increased non-aggressive loading without sacrificing the surface morphology when proper film formation process is involved. And finally, the receptivity of tubular does not vary significantly until the loading amount reaches threshold value but decreases practically above the threshold value at the loading amount of approximately 20 milligram per milliliter. My talk now finished. Thank you for your kind attention.